Hello, welcome to Xamarin University, and thank you for joining me here today for this recorded presentation of XAM151, Cross-Platform SOAP-Based Web Services. My name is Adrian Stevens, and I'm an instructor here at Xamarin University. Now before we get started, please make sure you've downloaded the class materials. You can get those at university.xamarin.com. Now for our exercise today, we can work on either a Mac or a Windows PC with Visual Studio. Now we are going to talk about a technique that will need to be completed on a Windows PC. It doesn't require Visual Studio to be installed, but you will need access to a Windows machine. It's not required to complete the lab exercise, but it is a good idea to at least try it out when you get the chance, and we'll talk more about that as we progress. So let's get started. So in this class, you're going to learn how to connect to a SOAP-based web service using the WCF support provided by Xamarin. Now this is an optional class, and it's a continuation of XAM150, and that's the class where we covered the REST service model, as well as how to detect the network connectivity and current network status on your mobile device. You should definitely make sure to take that class if you haven't already to get more in-depth information on those topics. But now we're going to talk about SOAP, so let's get started. And we're going to cover several things. First, we'll do a brief introduction on the technologies involved, specifically SOAP as a web service architecture and WCF as the framework that we're going to use to consume it. And then we'll get into the details of defining a WCF client and how to use it to access a SOAP service. To start with, let's define what SOAP is. Now, SOAP was created in the 90s to define a cross-platform way to get a client and server to communicate over a network. And prior to SOAP, there were no real standards that everyone agreed upon for performing network operations. The client just had to know exactly how to talk to the server. And so, in many ways, SOAP was really an amazing statement, a fantastic accomplishment. It was the first time that the big companies, IBM, Microsoft, Google, Apple, and even Oracle, actually agreed on something and supported interoperability between their platforms. And it signaled the end of most of the proprietary technologies which had tried to solve this problem previously, like COM and COBRA. Now, SOAP at its core is very simple. It describes an extensible data payload and is based on XML and transmitted over HTTP with a defined structure that we call the envelope, and it identifies the specific operation to be performed. Now, this core definition is referred to as the WS basic profile. Now, other things that can then be added to the call, to satisfy common enterprise requirements such as security, reliability, and transactions. And these additional features are defined in additional specifications, and we refer to these as the WS star or WS splat specifications. Now, not every specification is available on every platform, but some of them, like WS security, are pretty broadly accepted. SOAP relies on HTTP POST to perform all of the API calls because it tries to model an RPC approach onto the web world. And so this, in many ways, does limit its usage as well as its scalability. And it is one of the reasons why SOAP has fallen out of favor in recent times and been replaced by other architectures such as REST. However, SOAP is still the most fully defined architecture, and it's commonly used in closed enterprise systems where tighter user-based security is required. And here you can see a comparison chart of SOAP versus REST. And right away we see, of course, that SOAP is very standardized compared to other protocols. It's very open in its transport, supports HTTP, FTP, etc. We see the data format is XML. Of course, we can embed other data formats within the XML payload. Now, WCF is the framework that we're going to be using to consume SOAP services. And WCF stands for Windows Communication Foundation. And it was added to .NET as part of the 3.0 release. And it's both a server-side and client-side framework, and was designed to deprecate all of the existing networking technologies which were being used in the Windows world at that time. And so because of this very ambitious design goal, WCF is often considered to be complex and can be a little bit hard to work with. It is extremely customizable, and it supports not just SOAP, but also REST, binary, message queues, and even UDP broadcast messages. Now, before we get into the meat of the APIs, let's talk just for a moment about the requirements to use WCF in Xamarin. Now first, you will need a business license or trial. The WCF support is only included in the Business Edition and above. And so if you're using the Free Starter Edition or the Indie Edition, then this support is not available and your application is not going to compile. Now second, because of the way WCF is constructed, you're going to need access to a Windows machine with the Silverlight SDK installed. You can do your development on any supported system, but a little bit of infrastructure code needs to be generated with some of the Microsoft tooling. And we'll get into those details shortly, but first, I do want to talk about how we define WCF connections. WCF defines services as endpoints. And each endpoint describes the location of a service, how to communicate with it, and what operations it can perform. And these three pieces of information are expressed as the address, the binding, and the contract. And these are sometimes called the ABCs of WCF, and are what you need to know in order to communicate with a SOAP service using WCF. And these three things need to be agreed upon. If the client and server are not in alignment, then the service call is going to fail. Let's look at each one in turn, starting with the address. So the address is the location of the service. And this includes the full URL, including protocol and port, where the service lives. And this may be a local address on a corporate network or a public internet address. And WCF itself actually supports a variety of protocols, including HTTP, TCP, named pipes, but Xamarin applications are limited to HTTP or HTTPS, and these are what SOAP services would use. Now, the second piece of information is the binding. And the binding describes how information will be transferred between the client and the server. And so this includes the format of the data, typically XML or JSON, but WCF actually supports binary and even custom representations. Now, other things described by the binding include message encryption, authentication, message reliability, and even high-level services such as distributed transactions. The desktop version of WCF is quite extensible and supports any number of combinations of features that you can stack and layer into the service. The mobile variety is a bit limited in comparison. Today, it only supports XML or JSON with HTTP. Higher level services are not included, but with the recent open sourcing of the WCF framework, it's possible to port the code yourself for some of these features. And it's very likely that some of the more advanced features will make their way into the core frameworks. Now, the final piece of information here is the contract. And the contract describes the operations available and how to invoke them. So, what data needs to be passed and what data is returned. In WCF, we describe the contract through an abstract type. most commonly an interface, and this interface definition can either be shared between the service and client or defined independently with the same shape. The contract is identified to WCF through a special attribute named service contract, and this has some optional properties to define the XML namespace and name of the contract. Again, this must be identical on the service and the client that's consuming the service. Then we define each operation available on the service as methods with parameters and a return value. And now the operations must be decorated with the operation attribute, which also has optional properties to allow you to customize the definition. So for example, you can use a different method name in the interface for clarity in your source code, but then match it to the proper operation name in the service. Here you can see we're defining operations related to courses that you can take at Xamarin University. Each course, of course, is identified by the class name, course. Once we have the ABCs defined, we need to deal with the data going back and forth. Recall, we're passing a course object back and forth. This will need to be serialized and then in an agreed upon format. SOAP often uses XML, and that's because the surrounding envelope is already in XML. Now, WCF itself utilizes a built-in class to do the serialization for you, and this takes your object graph and turns it into that XML. However, this is an extensibility point. You can tell WCF to use an alternative serializer either for performance reasons or to change how the data is expressed on the wire. So for example, there is a DataContractJSON serializer which turns your object graph into JSON, and you can use third-party libraries as well, such as json.net. So the serializer classes need some information on how to turn your classes into data, and they do this using attributes. So we decorate the class itself with the DataContract attribute. Again, we can specify the namespace, and by default it uses the C# namespace, which generally is not what we want. Now the fields must be public properties in the class, and we decorate them with the data member attribute, which lets us control the name, order, and whether it's required or optional in the data. And if you do not mark a property with the attribute, then it will be ignored by the serializer. Although it is worth noting that in more recent versions of WCF, they tried to make this a bit less clumsy by allowing you to omit the attributes altogether and just serialize all public properties. And this allows you to use existing data structures that maybe you don't control or define across the wire. However, it's an all or nothing approach, and if you include the attribute on one property, then you're going to need to deliberately decide which properties to serialize. Now this might be tempting, but for best practices, you really want to treat these objects as data transfer objects, use them specifically for the network representation. Try to avoid putting any logic in them and be deliberate with your attributes. So instead of the default no attribute approach, and you want to do this because it's going to give you more control, and it also forces you to think about what you're passing back and forth. Now, one of the advantages, or sometimes disadvantages, of SOAP over REST is that it's more fully defined. Again, SOAP has its origins in RPC-based transport, such as COM, which had a description contract to let clients know how to communicate with the service endpoints. And COM used type libraries for this purpose. And you could hand a client the type library, and they would have all of the information necessary to call that COM service. Now, SOAP includes this description contract through a related specification called WSDL, or WSDL. And this stands for the Web Service Description Language. And this is an XML file which describes the ABCs for the endpoint. It tells you the address, format, and the operations along with the data that are used for the service. And the WSDL is broken into two sections. First, we have an abstract section which defines all of the XML data types and the contracts that use them. And then we have a concrete section that defines the addresses, ports, and protocols used to call the interfaces. Since WSDL is expressed in XML, it makes it machine readable. So tools can read the WSDL, possibly obtained directly from the service online, and then generate the code necessary to call the service. If you've done anything with SOAP in the past, then you're likely familiar with the add web reference or add service reference features that are built into your favorite IDEs. And these features read the WSDL and create a C# or VB.NET code for all of the data contracts and service contracts in WCF terms. And this is an amazing feature, and it makes it dead easy to use SOAP-based services in .NET applications. Unfortunately, it doesn't work for us in the mobile world. That feature relies on desktop-specific implementations of WCF, and they're not supported in iOS, Android, or Windows Phone. So, as convenient and fantastic as that feature is, don't use it for your mobile applications. Instead, this is where the Silverlight SDK comes in. Xamarin supports the same subset of WCF that Silverlight does. You can hand create your contracts and proxies, but an easier approach is to switch to a Windows machine and generate the code from the WSDL using the SL-SVC util tool. Now this is a tool, it ships with the Silverlight SDK, and you use a command prompt to execute it. But you do not need Visual Studio for this. Now a quick point I need to make. Do be careful what you type. There's another tool with a very similar name, which is SVC util. It's just missing that SL prefix. And it does basically the same thing, but it generates that same desktop code as the IDE and can't be used. So do make sure you're using the Silverlight generation tool, the SL-SVC util. Now the tool will generate a single C# source file with a set of classes to describe all of the data contracts from the WSDL and a proxy class with methods for each of the operations exposed on the service. The proxy will do all of the work of packaging up the request into an HTTP post call and returns the results, making the web service call look very much like any other method call. You can then take this generated C# file and add it to your project. Now to compile that file, you will need to add the proper DLL references. Again, keep in mind these are only supplied with the business edition or higher of Xamarin. And you'll need system.serviceModel, system.runtime.serialization, and system.servicemodel.web. With all of that in place, we can then invoke the service methods. And the SL-SVC util generates a convenient proxy class, and that wraps up all of the operations. Now, when you create the proxy, you must supply the binding and address to the service. In the desktop world, this is often supplied through the app.config file, but it must be manually supplied in the mobile world. And here you can see we're using the only supported binding. That's the basic HTTP binding. This is XML with HTTP or XML with HTTPS. Then we utilize the methods to invoke the service operations. And since this is a network operation, the generated proxy uses the event-based asynchronous pattern and exposes a start method and a completed event for each operation. To use the methods, you would wire up to the completed event and then call the start method with the parameters to issue the request. You get the response in the event callback. And the callback is invoked on the background thread, which issued the operation. So you will need to marshal back to the UI thread if you want to update the user interface, or enable cross-thread bindings in Xamarin Forms if you're using the binding engine. So now that you've seen all the moving parts, let's try this out with a lab exercise. So let's all switch over to our downloaded course contents. So please open the downloaded folder, open the lab materials folder, and open the start here HTML. Of course, note we have the overview, the expected duration, and I like to point out the link under lecture. This is a PDF version of the slides that I'm using to present today. And what I'd like you to do now is our first and only exercise, and you're going to call a SOAP-based book service. This exercise should take you between 30 and 45 minutes, and when you begin, I'd like you to pause the video. And you're going to work from an existing Xamarin Forms application that's included in your downloaded course contents. And you'll get a chance to implement some basic SOAP operations. And at the end, you'll have a fully functioning SOAP client that allows you to interact with a service that is live online. If you open up your Part 1 resources, you will find a start solution. I'd like you to open that up now, and please start exercise number 1. Pause the video, and we'll do a review of the exercise once you've completed. Please start now. And please keep in mind there is a completed version of the project included in your downloaded resources, and I've opened that project here. Now you do all the work in your common code, and because this is a Xamarin Forms application and this particular solution is PCL based, we're working in that PCL project. And if you look at the data folder, let's take a brief look at the books.cs file. And this is the generated client. And this is what's generated by that SLSVT util application. And although you weren't required to generate this yourself for this exercise, I do recommend trying this at least once when you have access to a Windows machine, and you can always compare the generated code with what we have here in the project, and you should see they'll be the same. And it does generate a substantial amount of code, and this of course generates all of our endpoints, all of our data transfer objects, and methods required to interact with the service. Now in our book manager class, this is where we're going to consume and interact with that books class. And we do some basic wiring. We have a helper method to get the client, which is just newing up our client, passing in the basic HTTP binding, as well as giving it the endpoint address. And then we do a lot of our basic service interaction, starting with the login. Now remember, of course, that the generated client is using async operations, but it's not using our modern C# async await pattern. It's using that event-based pattern. But we can use the task completion source to wrap that up and really bring us back to that modern C#5 styling, which is exactly what we did here, as you saw in the exercise notes. And you can use this task completion source throughout all of your methods to simulate this behavior, or to use this task-based async await behavior. And if you look through the completed solution, you'll see this is done in all of our methods. Again, we see it here in our getAll method. We're newing up that task completion source. We're marking our method as async and returning our enumerable collection of book objects. And again, you'll see this the whole way through. And with this completed solution, we now have a fully functional application that's able to retrieve information, add new data to the service, and of course update and delete as well. Really a fully functioning application using that SOAP-based web service. So we've covered quite a bit today. We learned what a SOAP service is. We learned about WCF. We saw how to create a WCF client, connect to a SOAP-based service, and then of course execute methods on that service. Really to do all of those basic CRUD operations. So create, read, update, and delete operations. Now because this is a recorded video, unfortunately of course I can't take your questions directly, but that doesn't mean I can't answer your questions. You're always welcome to email myself. It's adrian.stevens@xamarin.com, or any of the other Xamarin University instructors. As well, please don't forget that you do have access to a dedicated forum as a Xamarin University student, and you can always book one-on-one time with an instructor to go deeper into any topics, or of course to review things like our SOAP-based web services. So I just want to say thank you very much for watching this recording of XAM151. If you haven't done so already, please do make sure that you watch the video, and even better yet, attend a live session of XAM150, which covers REST-based services as well as detecting connection states on your mobile devices. So again, thank you very much, and I hope to see you in a live class very soon.